what do you do if you have no idea how many solutions there are? There's one easy thing. Picture. Psi. Alpha. Theta. So what does each step of the algorithm do? So this is angle theta over 2. It rotates by an angle theta. So let's just pick a random number of iterations and try that. Well, what is this algorithm doing? It's slowly progressing around the unit circle at a constant rate. So what happens if we pick a random point on the unit circle, which if we choose a random number of iterations, and this number of iterations is large enough, it's a random number of unit circle, and measure in the basis alpha theta, which is equivalent to checking whether this point is a solution or not. Well, we get beta with probability 1/2. If the number is bigger than what's our pi over 4 root m over n, pi over 4 root n over m, get a solution with probability 1/2. So what you can do is you can guess that there's a lot of solutions. Try that. If it doesn't work, guess that there are fewer solutions. Try that. And if it doesn't work, guess that there are fewer solutions and try that. Because each time you're doing it with more iterations, and eventually you will run into a solution. So just start by picking a random number between, well, suppose you have some idea of how many solutions there are, although it doesn't really matter. So let's start by assuming that 1/10 of them are solutions. And then you would run it for pi over 4 times root 10. And if that doesn't work, assume, sorry, a 20th of them are solutions and run it for pi over 4 root 20, or rather, not pi over 4 root 20, a random number of iterations between, say, pi over 4 root 20 and 2 pi over 4 root 20. And you keep on doing this. Eventually, the number of iterations is bigger than this. And as soon as that happens, you have a probability of 1/2 of finding a solution. So this might not be the optimal thing to do, but it certainly is easy and it works pretty well. And I should say that Grover's algorithm, if all you're allowed to do is query the oracle, this number is actually the right answer. You cannot do much better than this, provably, with quantum computer.